Good day everyone. Now I want to solve example 2.6 using rectangular component method. We start off by drawing force P first. This is force P with unknown magnitude P. The angle of P with respect to vertical axis is 15 degrees. We know that P has a component along BC, or P has a component that is parallel with BC, and this component is called PBC. The angle of PBC is given, which is 40 degrees with respect to vertical axis. Another component of P is parallel to member BA. We call this component of P as PBA. The angle of PBA is 60 degrees with respect to horizontal axis. Now what we are going to do, we will resolve all of these three forces into its component along x and y axis. Normally we will take x axis as pointing to the right, y axis is pointing upward, or basically x positive to the right, y positive upward. So in vector form, vector P is equals to PBC plus PBA. If we resolve these forces along x and y, we can solve this along x and y separately. So what we have along x-axis, Px should be equals to PBC along x plus PBA along x. While along y-axis, we should get Py equals to PBC along y plus PBA along y. Resolve all these forces along x and y. We'll start off with force P first. So P along x is equals to P sine 15 degrees, and the sign is negative. While P along y is equals to P cos 15 degrees. Again, the sign is negative. To prove it, this will be the component of P along x and y. So this is Py, this is Px. So we can see it clearly that Px is negative while Py is also negative. Now we move on to force PBC. So component of PBC along x is equals to PBC cos 40 degrees minus, while PBC along y is equals to PBC sine 40 degrees, again minus. So to prove it, I'll draw the component of PBC here. So you can see this is your PBC along y and this is your PBC along x. Both of them will have a minus sign. Lastly, we will look into PBA. So component of PBA along x is given by PBA cos 60 degrees, while component of PBA along y is given by PBA sine 60 degrees. The sign here is negative. PBA x has a positive sign. To prove it, again, I will draw the component of PBA here. So this is your PBA along x and this is your PBA along y. We can substitute the value of Px, PBCx and PBAx into this equation. So P along x is minus P sine 15 degrees. PBC along x is equals to minus PBC cos 40 degrees. PBA along x is equals to PBA cos 60 degrees. We can substitute for values that we know. For example, we know magnitude of PBC equals to 500 Newton. We have minus P sine 15 degrees equals to minus 500 cos 40 degrees plus PBA cos 60 degrees. So this will give us the first equation. Now we want to solve along y-axis. Py equals to minus P cos 15 degrees, while PBC along y is equals to minus PBC sine 40 degrees, and PBA along y equals to minus PBA sine 60 degrees. Substitute the values that we know. We will have minus P cos 15 degrees equals to minus 500 sine 30 degrees minus PBA sine 60 degrees. This will give us the second equation. Therefore, we can get equation 3 from equation 1, equation 4 from equation number 2. We can get PBA as follows from equation number 3. Next, we will substitute PBA into equation number 4. By substituting PBA into equation 4 and rearranging, we get P equals to 696.45 Newton. By substituting P into PBA equation, now gives PBA equals to 405.28 Newton. Now we continue with B portion of the question. So the easiest way is to draw the component of force. This is PBC and the angle is given in the question, 40 degrees. The component of this PBC is along U and V axis. So this is U axis, this is V axis. So we need to resolve this PBC along U and V, or basically along axis that is parallel with U and V. So to make it easier, I can extend the length of this U axis. The angle here is 40 degrees, so the angle here is also 40 degrees. Thus, PBC along U can be written as PBC cos 40 degrees, and the sign is negative, while PBC along V is equals to PBC sine 40 degrees, and the sign is positive. PBC along U is negative because the component of PBC along U is actually this vector, while component of PBC along V is this vector. That's why PBC along V is positive along V axis. Therefore, we get these values for component of PBC along U and V axis.